Imagine opening up your phone bill and spotting something strange. Right there, in the logs, is an unknown number making a call lasting exactly 1 second every single day, right at 3 a.m. You'd know immediately that something was wrong. Humans are messy and unpredictable. A person doesn't wake up at the exact same minute every night to make a 1-second call. That pattern is rigid, mathematical, and clearly automated. Computers operate the exact same way. They rely on a digital directory called DNS. It's like the internet's version of the contacts list on your phone, translating the website names we type into the actual computer addresses the machine needs to find. Every single time a device visits a web page, sends an email, or silently updates an app, it has to look up a destination in that giant internet directory. And every single time it looks up a name, a record of that call is saved. This is the central problem for hackers. They can write highly sophisticated software designed to sneak past scanners and sleep silently on your hard drive. But to actually do anything, that software has to use the internet. It is forced to make those mandatory calls to the directory. By taking those logs and turning them into simple graphs, cybersecurity experts don't even have to look at the malicious code. The attackers inadvertently draw highly visible, distinct pictures of their own movements. Today, a modern cybersecurity dashboard looks more like a heart monitor than a wall of code. Defenders are searching for shapes and rhythms in the data that don't belong. The first signature they look for is called a heartbeat. When sleeper malware infects a machine, it stays quiet. To figure out what it should do next, it periodically checks in with the attacker's main server. On a traffic monitor, this creates a very specific line. You will see a completely flat line of zero activity, broken only by identical, sharp spikes of requests. They repeat exactly on the hour or exactly every 7 days. It's that robotic, non-human pattern revealing itself again. A second visual signature points to DNS tunneling. This is how attackers quietly steal internal data and smuggle it out through a company's tight security filters. This comparison shows the smuggling operation. On one side, normal traffic flows to short website names. On the other side, a steady stream heads to long, jumbled strings of letters and numbers. These characters are tiny fragments of stolen information, shredded to sneak past security. Attackers want to stay hidden, but the techniques they use to stay stealthy either require unnatural, rigid routines or heavy disguises that stand out visually against normal traffic. Of course, once defenders spot an attack coming from a specific location, they just block it. If an attacker sits still, they'll be cut off in minutes. To survive, attackers use our third signature, a technique called fast flux. Instead of hiding, they shapeshift. They take a single malicious website name and quickly associate it with hundreds of different addresses. They instruct the victim's computer to constantly ask the directory for a new location, sometimes every 5 minutes. This scatter plot shows what that rapid movement looks like. Connection points are flashing, expiring, and jumping to new coordinates almost constantly. By attempting to outrun security filters with lightning-fast location changes, the attacker generates a frantic footprint that is easy for experts to identify. Other hackers don't rely on speed. They rely on time. They build traps and wait quietly for the perfect moment or the perfect victim to cross their path. This brings us to the fourth visual signature, sleeper domains. Sophisticated hackers will register a website name and leave it totally inactive for years. The goal is to age the site so security software assumes it is safe and trustworthy. This timeline graph reveals exactly when the trap is sprung. You see a flat line of zero activity stretching across years, which instantaneously erupts into a massive mountain of traffic. The site has been woken up. Our fifth signature relies on human error. These are phishing scams. Fake banking or retail sites designed to trick office employees into handing over their passwords. This chart tracks connections to a fake website. The traffic is very spread out and only happens during this highlighted 9 to 5 window. A victim clicks the link, falls for the trick, and rarely returns, leaving the site silent during the night. Whether it's a trap that took years to build or a quick trick aimed at an office worker, the specific timing of human interaction creates a shape that betrays the scam. Recognizing these shapes is vital, but the internet is massive. It is physically impossible for human security guards to manually read millions of directory lookups occurring every single second. To handle this overwhelming flow of information, modern cybersecurity uses machine learning. These specialized tools are built to automatically ingest millions of logs and convert them into the visual shapes and patterns we've been looking at. In this split-screen view, you can see the system working in real time. The AI continuously scans the traffic rhythms. It learns what healthy, normal movement looks like, and the second it detects the rigid spikes of a heartbeat or the chaotic jump of a fast flux, it blocks the connection. Hackers can write complex, invisible code to compromise a machine, but they cannot hide their behavior from visual analysis. The internet's address book records every click, and for the people guarding our networks, these visual traces are the first step in catching a thief.